All right, we are going to finish up 7-1 today. So we did about, 2/3 of it yesterday, so we're only going to do about a third of it today, and then I will give you some, let me see. Yeah, then I'll give you some homework problems to do, and you might even have time in class to get some of these done. All right, so let's review quickly. We did this stuff yesterday. Do you have your notes in front of you? We did 2 areas yesterday, didn't we? We did area of a what? Trapezoid. So again, I've said this on a couple occasions, maybe more than a couple occasions. Should be keeping a little list of all the formulas that we know. I'm not going to go through them all right now, but I am going to do what we talked about yesterday. So yesterday, we talked about the area of a or was it yesterday? Yeah, it was yesterday. We did that in a kite, correct? All right, so the area of a trapezoid, do you remember what that was? It's a T, kind of like triangle, so you know what the area of a triangle is, right? So the area of a triangle is just 1/2 the base times the height. So a trapezoid is very similar. We talked about the similarities yesterday. It's very similar to a trapezoid, even though a trapezoid's got 4 sides and a triangle has 3 sides. It's very similar. Remember, if we lopped off top of the triangle, we're left with a trapezoid. So the area of a trapezoid is kind of the same. Jason, tell me. It's 1/2. Right. It's the 2 bases. Remember, a trapezoid has 2 bases. A triangle only has 1 base. So instead of the area being 1/2 the base times the height, it's both bases. And what do we do to both bases? We add them up. All right? So that's 1/2 the base times the height. Very, very similar to the area of a triangle, except what do we do with the 2 bases? We just add them up. So that should be in your brain right there. Okay, you should remember that. At least it should be on your list of things to study, right? Because if you keep one list, then you don't have to keep flipping pages and looking to see which equations you're supposed to be remembering. All right, if you keep one list, you're going to have them all, and you can study from that one list. So this should be one of the things on that list. What were the other things before the trapezoid? Area of what? Rectangle, triangle, square, parallelogram. Remember? Parallelogram. And I think that was it. Anybody keeping a list? Is anybody actually doing what I asked you to do?
Yeah.
Okay. So those should be on the list. This should be on the list. And what was the second thing we did yesterday? A kite. Area of a kite. All right, so the area of a kite, I'm not going to draw it. We did this yesterday, but I'm just going to write down the formula for it. So the area, I'll put K for kite, equals. Now, we don't just use the sides of the kite. What do we do to the kite? We draw the diagonals, okay? So the area of a kite has to do with the diagonals, all right? So you got to know the diagonals of the kite. So do you remember what the formula is for the area of a kite? Starts off with 1/2, just like the triangle, just like the trapezoid. Still starts off with 1/2. All right, so that's something to remember. Now, what do we do to the 2 diagonals to find the area? Multiply them together, that's right. So we're going to call one D1, and we're going to call the other one, guess what? D2. All right, so that right there is the area of a kite, if you know the diagonals. All right, so if you know the diagonals, multiply them together, take half of it, and that's the area of the kite. Pretty simple, isn't it? Yeah. I mean, each of them by themselves are pretty simple. It's remembering them all is the problem sometimes. But we're doing it little chunks at a time. Okay, I'm not like throwing 15 formulas at you at once. We're doing a little bit of a time at a time. So, and you should be keeping a list, like I said, so it shouldn't be that tough. Yes. Of course. Anybody else want to leave? Seems like everybody's leaving now. Let's do another. Let's learn a new form. It's not even a new formula. But we are going to do it with a new polygon. Okay, question. Oops. Let's try that one. There we go. Well, it was on the video that you watched last night. You took notes on, right? Yeah, it's 71 with 18 holes. Or 9 holes? 18 holes would be great. Well, for me, 5 holes, 71 would be good because my golfing game is, I don't know. I'm not quite that bad, but I'm not a very good golfer. I'm a disc golfer, though. Did you know that? Did I ever tell you that in here? Well, I don't know if I would say I am a disc golfer. I'll say I play disc golf. I don't know because I'm not good enough to call myself that. Yeah, it's like frisbees at a chain. Exactly. Yeah, I do the what dance? What you call it? The thug shaker? Is that what you call it? All right, show it to me. You're dying to. Do it quick. Come on.
So like you put your hands up.
Just do it. Just do it. That's a thug shaker. I'm not doing that. I promise you, I will not be doing that. I will not be doing that. You're gonna have to. You're just gonna have to wait. The only time I'll ever do that is if I'm in my coffin and somebody drops it and I wiggle around. That's the only time that's absolutely the only chance that you'll ever have of seeing me do that. All right, sit down. Sit down. You had your fun. That's it. All right, here we go. What is this thing right here? All right, let's listen now. What is this thing right here? This is a rhombus. Everybody look. Shh. All right, we had our little fun. Let's watch now. Let's have more fun watching these rhombuses, or rhombi. I think that's a plural, a rhombus, I guess. Rhombi. All right. So check this out. What's really nice about this, and you'll be very happy about it, I'm sure, is that we do have diagonals. We've actually talked about diagonals of rhombus before, didn't we? What do the diagonals of rhombus do? They do bisect each other because it's a parallelogram. They do bisect each other because a rhombus is a parallelogram, right? And they do bisect each other on parallelograms. So they definitely bisect each other. But they do something on a rhombus specifically. They do something on a rhombus specifically that's only true about a rhombus and not true about a rectangle, not true about any parallelogram. What do they do that's specific about a rhombus, Jason? They're perpendicular to each other. That's right. So they do form a right angle right there, okay? So that is something to remember. That's not new. That's old. So it's just something to remember. Again, I'm not going to go through this and show you how they got this formula. Okay, I've got it in my notes. I could do it, but I'm not going to. All right, but what's nice about the area of a rhombus is that it's exactly, the formula anyway, is exactly the same as the area of a kite. All right, so there you go. You got 2 for 1. All right, so you got 2 equations. You only have to memorize one, or yeah, you got 2 areas, 2 area formulas that you only have to know one of them because it works for both. So the area of a rhombus would be what if it's the same thing as the area of a kite? It would be 1/2 what? Yeah, diagonal 1 times diagonal 2. All right, so if I call that D1 and I call that D2, it'd be the whole entire thing. Remember, it goes from corner to corner. So if I multiply those 2 diagonals and then take half of it, don't forget to do that because that's part of our formula right there. That is the area of a rhombus. So if I wanted to find the area of this thing right there, and I knew the diagonals, multiply them, divide them by 2, and you've got your area. Pretty simple, isn't it?
Yeah.
Good. Thank you. Thanks for the enthusiasm. All right, let's do another one. Let's do an example, okay? So I'm going to put some numbers in here. I'm going to flip this the other way. So let's see, what do I do? Transform, then shear, and then I go to negative, make it -20. Oops, I got to do it again because I just took it back to being a square. Let's try that one more time. Go to shear. There we go. All right. All right, it's the same thing. It's just tilted the other way. I just want to make it look like the example. All right, so they tell you that this is a rhombus. It says, the question says, find the height, and I'll put some stuff in here in a second. I'll give you some numbers, letters, and all that good stuff. All right, find the height of the rhombus. How do we spell rhombus? R what? R-H, that's right. All right, so that's the area of the rhombus. All right. So they tell you the bottom of this thing is 5. Let's put some diagonals in here, right? Because if we're going to go area, got to have some diagonals. And they tell you some of these. So they tell you this one right there. And we got, I'll tell you what, let's do a different, it doesn't matter if it's a different color. Let's just go right there. All right. And they tell you that this little bit right there is 3. They tell you this little bit is 4. And what they're asking, we'll definitely do this in a different color. Go blue this time. They're asking for the height. Now, we've talked about this before. Let's remind you again. What am I talking about when I'm talking about the height? So if I had a point right here, and if I had a line right here, okay, where would the height be? It'd be perpendicular. Very good. We got it on the first shot. So the height would not be from there to there. It wouldn't be from there to there. It would be what? It would be perpendicular. Everybody with me? Mm-hmm. So the height, when we talk about the height of something, it's got to be perpendicular to the base. So let's take a look at this. Are any of these sides right here the height? Like, is this thing right here the height? No, it's not, because it's not perpendicular to this one right here. So what in the world would we have to do to find the height? Well, let's take this. Let's extend it out a little bit. See that bottom? I just extended it out. So if I wanted to find the height, I would go from here, this top one, where? Is it there to there? Is that the height? Is it to there? Is that the height? Is it here? It's perpendicular. That's right. It's perpendicular to the base. So you could just extend the base out a little bit if you wanted to. All right, and then this blue one right there would be the height. That's what they're asking for. You could do it another way. This way's a little bit cleaner. It's a little bit nicer. You could have done this. Don't draw this one because I'm going to erase it after I'm done drawing it. You could start from the top and go where? Perpendicular to there. Do you agree that both those blue ones are exactly the same? So that would be the height, and that would be the height. This is just a little bit messier. So this is a little bit nicer because it's outside of all this stuff. So I'm going to use this one right here, okay, from the top down the bottom. If I wanted to, I could start anywhere up here. I could have started here and gone perpendicular to the base, couldn't I? Any of those blue ones that I just drew would be considered the height of the rhombus. But I'm going to use this one right there. Thank you. All right, so what in the world do we do? Well, first of all, we know, what's the angle in here? Because 90-degree angle. That's a right angle. Would you agree? Because they're perpendicular to each other, because this is a rhombus. All right. Now, what else do I know? Actually, let me think. Okay, I see it. Like, how does area have anything to do with this thing? All right, yeah, this one's a little trickier. I had to look at my notes for a second, okay? See where we're going with this. Let me see how to explain this. Remember what we talked about this earlier. What do these two diagonals do? They make a right angle, but they also bisect each other, right? So this one right here is 4. What about from this corner to this right here? What is that?
4.
That's 4 as well, isn't it? So what would it be from this corner, this whole diagonal, from here all the way to here? That'd be 8. Would you agree? Okay. What else? What else do you think? Yeah, this would be a 3 as well, so that would be a 6. Okay, we may use that. We may not use it. I'm not sure. But let's see what we could do here. Um, so it's not asking for area, but it is asking for height. Check this out. Let me put this in a different color. Let's go yellow. And let me make this line, I think, oh, here it is. Let's make this just a little, let's see, where's my, oh, here it is, it's right there, stroke. Let's make it a little bit thicker just to kind of show you. Now watch this. I want you to see something. You've got this, and we do this, and then from here, and then from here. Do you see this yellow triangle? Okay. Now, what is part of this yellow triangle that we're trying to find? The height. Would you agree with that? Okay, I'm going to try to find that height right there. Okay? And, do I want to do that? I should have looked at this before I explained it. I've got it right here in front of me. I know exactly what to do. It's just, you know what? I don't think I want to go with that triangle. Yeah, I'm sorry about that. I saw that, but I don't think I really want to go there. What if, let me ask you this, and let's change this back. What? Yeah, it's being recorded. All my fumbling and messing up is being recorded for everybody to see. All right, but so here we go. Watch this. What if now? Yeah, that's fine. I'm just trying to get my thoughts together. So it happens to me. It happens to everybody. Right here, look at the area of the rhombus. If I want to, I'll show you where it works. I'm trying to get you to think how. Stop. Why would you do that? I don't understand why you would do that. Stop. I'm trying to put myself in your shoes where you're looking at this and you're like, okay, where do I go next? All right. And I'm having a hard time doing that. I'm just going to show you what I did. Okay. If you wanted to find the area of this rhombus, what would you do? What's the formula again? It's 1/2 D1, D2, right? Do we know D1, D2? We do. Okay. Now, here's what I'm struggling with to get you to understand. But I think once you see me do it, then you're going to look back on it and you're going to say, oh, okay, now I see why you did that. I'm trying to put myself in your shoes to think, what do I do next? And that's what I'm having a hard time with. But you'll see it work out real nice. So let's find the area of that rhombus. Okay, so its area is 1/2 D1. So what's one of the diagonals? It's 6. Okay, that's the 3 and the 3. What's the other diagonal? It's 8. It's the 4 and the 4. That's where I got the 8 from. Everybody see that? Okay. And now let's do that. Well, 6 times 8 is what? 48. Take half of it. It is 24. But that's not my answer because they don't ask me for the area. And you're probably thinking, well, how in the world or why in the world would you even find the area when they're not asking for the area? Well, it's a good question. I'll show you. So the area of this whole thing is 24. Okay. Now, where does the height come in? The height is not the diagonals. Like, where in the world does the height come in? Now, here it is. Go ahead, Nathan. What do you think?
5 from 24.
No. You do? How do you know that?
Because it's just like when we're trying to find like the square or any other shape, we have to, since you add up to get that area, you add the two sides together. We're trying to get like find out what one of them is and we have the other.
Yeah, I think your explanation was a little clunky, but you were right on though. But you're definitely right on. Okay, so let's take a look. See if I can get my explanation to be any better. I don't know if I can or not, but let's see it. So this is a rhombus, but it's also a parallelogram, isn't it? Okay, and we have a formula for just any general parallelogram. All right, and I'm going to show you why I'm thinking of this. I'll show you in a second. So what's the area of just an ordinary regular parallelogram? It's the base times the height, just like it is the rectangle. okay? And you may see this now. Knowing this, that the area of a parallelogram is the base times the height. Again, this is a parallelogram. Well, guess what we just found out? We just found out what the area is. So where can I put that? I can put that right there. What here do I know? I know the base. I know the base of this parallelogram, okay, or rhombus. And what is the base? It's 5. And what am I trying to find? Now, this is the key. I'm trying to find the height. So I needed an equation with the height in it, didn't I? All right. This area of a rhombus didn't have the height in it, but it did have the area, okay? So you think of another equation. Area is base times height because it's a parallelogram as well. I'm like, wait a minute, that's got the height in it. So if I knew the area and if I know the base, then I should be able to find the height. Do you understand why we went to find the area of this, even though they didn't ask for it in the first place? I think that was a pretty decent explanation. Do you? At least I understood it. I don't know. So let's put the stuff in here. So what is the area of the whole thing? It's 24. Now what's the base of this? The base is 5. And then the height is just h. It's h. We already labeled it right here, okay? And now this is what Nathan said. He said, can't we just take the area and divide it by the base? And absolutely, that's what we're doing right here. This is where we do it. So we divide it by 5, we divide it by 5, and the height comes out to a decimal, but it's 4.8. And that's the height right there. So that's how tall that blue one is. It's 4.8. It's not as long as the length of the side, is it? And it shouldn't be, because look, this is a right triangle. This would also be 5, wouldn't it? All right, so that can't be the same length as that. It's got to be a little smaller, and it definitely is. And it's 4.8. So that's how we do it. So that really took some forethought. This took looking ahead a little bit. All right, looking at this and say, okay, well, do I have a formula for height and rhombus? Or, I really don't, because really the only equation I know about a rhombus is this one right here. But I do know that it's also a parallelogram. This is where you might have not been able to do this yourself, okay? So you knew it's a parallelogram. You're like, wait a minute, I have a formula for parallelogram, and it's this one right there. That's got height, it's got area, and it's got base, all right? I know 2 of the 3 things, and now I can find it. Yeah, you do have to put the units. I didn't put the units up here, so I didn't put units here. In the book, it is in meters. Everything is in meters. So what's your height? Is it meters squared? It's just meters, right? Because that's just a length. The area would be squared. So if I asked you, if part of the question was find the area of this, then you would put meters what? Squared, okay? So that was a little bit tricky, wasn't it? All right, because at first you're like, how in the world do I find the height? Because I don't have a formula. When I use that diagonal, or the area of the rhombus with the diagonals, I don't have height as part of that. All right, so I got to have something else. So you think of another formula. What's another formula I could use? Well, it is a parallelogram, even though it's a rhombus, right? All rhombuses are parallelograms. So I do have an area for a parallelogram formula. Boom, right there. All right, I just found the area using this rhombus formula. They tell me the base of it is 5. I can just do a little math and solve for the height, and we're good to go. All right. If you didn't understand that, go back and look. Forget all the stuff I did with that big yellow triangle. Skip through that part. I fumbled through that. All right, but we finally got on track. And this, starting right here, when you see this on the video, watch this all the way through, and that should make sense to you. I hope. All right, so that's section 7.2. So here's the homework. So it's section 7.2, and it's 1 through 14. It's page 308, 309. 308, 309. That's it. You got 15 minutes. Let's use the time wisely to start working on this homework. I'll walk around. If you have any questions on it, I can help you out. Okay, so let's use the time wisely to get some of this done so that you don't have to do it all over the weekend. You do have a long weekend, though.